All right, so I finished my general announcements, and students were reminded to turn in the take-home supplemental portion of the Chapter 4 test, which is due today, dead tomorrow. And we're going to get through 5.16 today. We're going to skip 5.17. We'll save that for tomorrow. We'll go right into 5.18. All right. So as a reminder, this is the simulation we ran at the end of the last class. We were given a random number table at the bottom of the page. We were told to start on row 4. The number assignment we had agreed on when simulating an 80% free throw shooter was 0 through 7 will represent a make, 8s and 9s will represent a miss. And in this particular case, we were interested in, okay, if you are an 80% free throw shooter, how long are you going to go until you finally miss? So you'll notice that every single trial ends with either a 9 or an 8 because every single trial has to go and go and go and go until this person misses. So in every single one of those collection of numbers, the 9 or the 8 is the end of the trial, and you'll notice that I marked it same thing down in the table below. I mentioned before that when you're running a simulation, the way you show your work is the way in which you mark the number table itself. Okay, now in this particular case, you either make or you miss. So if there's only 2 options, you can get away with just marking the makes or just marking the misses. But if we were running a simulation where certain numbers were a cat and certain numbers were a dog and certain numbers were a mouse and certain numbers were a bear, well, now you kind of have to mark every single number because it needs to be clear how every single number is being interpreted because there's more than 2 options. Okay. All right. So what we're going to start with today is, what if I gave you this exact same setup, but I told you to explain to me the simulation? Like, tell me what you're going to do. Okay. So the box below shows how a simulation design may be written. This is what you would have had to do if asked to design the previous simulation. A thoroughly written design should include each of the elements listed below. So this is a fantastic write-up where if I gave you these, if I gave every single one of you this directions in a box, and I gave every single one of you this number table, you all should be able to run the exact same simulation. Okay, now, because some of you might use each line for its own trial, maybe you get slightly different results, but the bottom line is what's in this box is enough to make you all do the same thing. Okay, so I'll use a random number table or generator such as my TI calculator to record random single digit numbers 0 to 9, with 0 to 7 representing a made shot and 8 to 9 representing a missed shot. Within each trial, I will continue to generate random numbers until I come to a missed shot. I will then record the total number of shots that were made prior to the miss. I will perform 10 trials and then calculate the average number of shots made. This is a summary of literally what we did at the end of last class. Okay, now as a grader, let's pretend for a moment this box is what you put on a test or quiz. Okay, I want you to experience how I'm reading through your work. Okay, because these vocabulary terms, component event, outcome, trial, response, there's no requirement that you use those exact words. But as a grader, I'm looking for, did you touch on those concepts or not? Okay, so after reading the design, identify each of these elements. What's going on in my head is, I know what numbers you're using. I know that you're using a random value to represent taking a shot. That's what I know. I know from the context, that's what you're simulating, a basketball player taking a shot. Okay, so that's what a number represents. It represents somebody taking a shot. But how are you interpreting the numbers? Oh, I know that too. You told me that. You said a 0 to 7 is a made shot and an 8 and a 9 is a missed shot. I would argue, by the way, maybe you don't really need to explicitly state that because, again, we're in a binary situation. You either miss or you make. So if you tell me 0 to 7 is a make, I'm willing to take the logical leap that everything else is a miss. Okay? Now, how are you running a trial? Like, now I know what you're doing with numbers, but how many numbers are you running in a trial? Is this like you take 10 numbers and you wonder how many they make out of 10? Like, what are you doing in a trial? Oh, I remember that. You said you were going to go after go and go and go and go and go until this person misses. And now I know your plan on how to conduct a trial. Okay, so you're going to do shot, 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 and once a miss hits, you're done. But what are you recording? Are you recording the number of misses? Well, that would be kind of silly because then every trial would be a 1. You told me you're running the trial until there's a miss. So if the response is the number of misses, then all you're going to get is a bunch of 1s. That would be kind of a silly thing to do. Okay. But now I know, oh, at the end, you're going to count how many shots were made before the miss. That's what you're recording. Okay, so now I totally get how you're running a trial. You're generating random numbers, 0 to 7 is a make. You're going to do shot after shot after shot after shot until a miss, and then you're going to record how many shots were made. Again, these are the elements I'm breaking down for you, a grading rubric, essentially. All right, how many times are you going to do this? Well, in the directions, we did 10 trials yesterday in class, and that was the same thing the write-up said. Okay, so now I'm picturing 10 trials that all end with an 8 or a 9, 10 response values that show how many shots were made. What are you doing with those numbers? Now that you have them, what are you doing with that? Are you going to look at the highest and you're going to say, oh, I'm going to take the maximum. An 80%, based on my simulation, an 80% free throw shooter is expected to make up to 19 shots in a row before missing. Is that what you're doing? You're looking at the maximum? No. In the write-up, you very clearly said you're going to calculate the average. Oh, that's what you're doing. And that's what we did last class. We added up all the numbers, divided it by 10, and we said on average, you're going to make around 6.5 shots. By the way, please don't be worried about a decimal. I know that on one specific trial, you can't make 6.5 shots. Averages are allowed to be ugly numbers. All this is saying is that if you watch this person do this over and over and over and over again, sometimes they'll make 6, sometimes they'll make 5, sometimes they make 9, sometimes they make 19. But the expected long-term average is 6.5. Okay? So that is your statistic. You're interested in the mean number of shots, or if you want to say average, fine, same thing. Mean number of shots made before missing. Questions? All right, so again, skipping 5.17, going straight to 5.18. I'm going to ask for volunteers to contribute, filling in the blanks. Okay? You are about to take a road test for your driver's license. You hear only 34% of candidates pass the test the first time, but the percentage rises to 72% on all subsequent retests. Use the random number table to run 5 trials to estimate the number of tests drivers take in order to get a license. Okay? After considering how you would design this simulation and identify each of the elements listed below in this context. Okay? So can anyone tell me, I'm going to go to my calculator and I'm going to use the randint command. And we're going to use some number range that we'll discuss in a moment. But when I hit enter and I get a number, what was that number used to represent? What was somebody trying to do? Because it wasn't taking a shot. So what I just heard was the number of tests drivers take. So if I do this, that represents somebody took a test 6 times. I disagree. We're not generating a number to represent the number of times someone took a test. Yeah. So if they pass or fail is actually what we're going to get into in the next part. But the bottom line is what you just explained is a random value represents you're attempting your driver's test. That's what a number represents. Somebody is sitting down to take their test. Okay, now Nakeith is absolutely right that in the end, they're either going to pass or they're going to fail. Let's try to break this down slowly because I added something to this simulation to try to make it tricky. I warned you last class that the simulations we looked at were kind of straightforward and the free response challenge is way more complex. This one has something added to it that makes it a little funky. So if we're trying to simulate a 34% pass rate, what numbers do we need to assign to passing that are nice and start at 0? 0 to 30, not 31, 33. 0 to 33 would be passing. Now, by the way, what that tells you is when we use our randint command, it's not enough for me to do that because I need numbers 0 to 33 to represent passing. So what do I need to do? To 99. This is what will allow me. Now, if this is a person that is down for their first test, I'm looking for numbers 0 to 33 to be a pass. So that is somebody who failed on their first attempt. That's somebody else who failed on their first attempt. That's somebody who passed on their first attempt. Does this make sense? However, when a person fails, the way this problem has talked about it is they don't just give up. They go back and they try again. So now let's imagine I've got somebody who, hey, I got somebody who failed. Well, now they're going back and they're going to try again. So I'm going to use this same command, except now it shouldn't be 0 to 33 because now what is their chance of passing? 72. So when I hit enter the second time, I'm no longer looking for a number 0 to 33. I'm looking for a number 0 to 71. Okay. So that is pass on the second try. Let's do this again. They failed the first time because it wasn't a 0 to 33. So now they're going to try again. They passed not because it was 0 to 33, but because it was 0 to 71. Okay. I'm hoping to find somebody who fails 2 times in a row. That's just a pass. That's a fail. That's a pass. I'm hoping to get 2 high numbers in a row. Fail and, dang it, almost a fail. But do you see what I'm doing? I'm hoping for that second number to be higher than a 71. Okay. So you have to explain this to me. Okay. So we are generating random numbers to represent attempting a test. But the way we use those numbers is going to be dependent on was it your first attempt or not. So 0 to 33 is passing your very first test, but 0 to 71 is passing any other test. Okay, so now I know how we're going to use these numbers. 0 to 33 is a pass. Then after that, 0 to 71 is a pass. How do I know when to stop? Like, should I stop right now? If I'm running a trial, should I stop? I got Luke nodding his head and I agree. Why should I stop? Okay, they passed. Exactly. Should I stop? Yeah, they passed. Dang it. Give me something better. Should I stop? No, because they failed. Now should I stop? Yes, because they passed. So in other words, a trial keeps going and going and going and going until you pass. Okay. Okay, so now let's imagine we have a series of numbers. Okay. And we're going to keep going and going and going until a person passes. What do we then write down? We're not going to write down whether or not they passed. That would make absolutely no sense because we defined a trial keeps going until they pass. So why would your response variable be, did they pass? It's every response variable will be a 1 because they all passed. You said you were going until they pass. So what do we record? How many tests they had to take, the number of tests. So how many tries did it take until they finally were able to pass? That's what we're writing down. Now in the directions, we were told to run 5 trials, so I'll just write that down right away. And the setup itself said estimate the average. So the setup of the question kind of handed you the last 2 things. Okay, so here's how this might sound in paragraph form, which by the way, if you would prefer to write a bulleted list, I have no problem. I don't care the structure of how you want to present this information to me. What I care about is, do you have these elements? So here's how it might sound if I was told to design this simulation. I will generate random numbers from 0 to 99, with 0 to 33 representing passing on first attempts. Otherwise, 0 to 71 is passing. Within a trial, I will go number after number after number until the person passes. I'll then record how many tests they had to take in order to pass. And when I'm done running 5 trials, I'll record the average number of times needed to take to pass. That's essentially how this could sound. Okay, as a grader, I'm looking for those elements. Do you understand what a number represents? Do you understand how to interpret the numbers? Do you understand how to run a trial? Do you understand what to write down when you're done with a trial? Did you make it clear how many trials you're going to run? And what do you do with all the results of all the trials when you're done? What is the statistic you're interested in? This is the same type of rubric and mentality I'm going to have when I'm grading your free response challenge. I'm going to ask myself, do you know what you're even trying to simulate? Do you know how to use the numbers to simulate it? Do you know how to run a trial? Do you know what to record at the end of a trial? Okay, that's what I'm going to be asking myself. All right, so now we're going to run this. Now we're going to take 2 digits at a time now because we're using numbers 0 to 99. This is how you can use a random number table. So the first number is not a 1, it's not a 5, it's a 15. Is that a pass or fail? That's a pass. So the way I'd mark the table in the very first one is check, and you only had to take 1 test. 15 was the outcome. That's a response of a 1. You had to take 1 test to pass. Next one, same thing. A 9 is passing. So we got 2 trials in a row. A person passed on their very first attempt. That's not particularly unusual to me because you have a 34% chance of passing. So it's going to happen quite often. Now, a 43 is a fail because it's not 0 to 33. How about a 41? Why is it a pass, Ray? Perfect, because it's 0 to 71. Okay, so the first number is a fail because it's not 0 to 33, but the second number would represent a pass because it is a 0 to 71. So our outcome are those two numbers. Our response is a 2. The next one I would argue is the only one that's kind of interesting. 95 is a fail because it's not 0 to 33. 80 is a fail because it's not 0 to 71. 78 is a fail because it's not 0 to 71. And finally, 66 is a pass. This would be a trial that represents somebody who had to take the driver's test 4 times in order to pass. Okay? Get the last one yourselves. I'll wait 30 seconds. All right, so for the fifth trial, you should have gotten 3. 45 is a fail, 80 is a fail, but 53 is a pass. So for the last one, you should have gotten a response of 3. Record the results of your 5 trials, then state your conclusion. Remember, our conclusion relied on finding the average. If you add up all those numbers and divide by 5, you get 2.2. Now, again, it's perfectly fine for your average to be a decimal that in context wouldn't make any sense for an individual person. It's not possible for one person to take the test 2.2 times. That doesn't make any sense. But that's not what you're saying. Remember, probability is about long-term averages. So this 2.2 says, if you find a whole bunch of people and ask them how many times they had to take the test, you expect the average of that group of people to be somewhere around 2.2. And law of large numbers would say, assuming that's even accurate, that in the long run, that number should get closer and closer and closer to 2.2, or whatever the true average is. So based on the simulation, the average number of driving tests to pass is 2.2. All right, last item of the day, top of the next page says, another student conducted the same simulation by generating their own random numbers using a graphing calculator. Use their trial results below to estimate the percentage of those tested still do not have a driver's license after 2 attempts. Question. If you're solely interested in drivers who still don't have a license after 2 attempts, what should you be looking for in the response column? A number greater than 2. Somebody who had to take it 3 or 4 or 5 or 6 or 7 times. How many of those trials resulted in a number greater than 2 out of the 20 trials? 4 of them. So, based on this simulation, 20% of people do not pass even after driver's tests. Now, the nerd in me included this question because later on in probability, we will learn how to calculate the correct theoretical value, which in this case is about 19.04%. So in theory, if you ran this simulation a couple million times, you would expect the proportion of people who needed to take more than 2 tests to approach about 19.04%. But that's something for much later on. That's a 5.3 topic. And we're done. So when you're done writing that down, feel free to pack up. Tomorrow will be kind of the same structure as today. We'll start with just breaking down a write-up, and then we'll run one simulation. Thanks for watching. Have a good one.